No one expected this from Toyota. Not the analysts, not Detroit, not even the EV diehards who believed Toyota had already lost the electric race. But overnight, the world's largest automaker may have changed everything. A road-ready solid-state battery. More than 1,200 miles on a single charge. A full recharge in just 5 minutes. No lithium bottlenecks. No cobalt dependency. No compromises. And this isn't some futuristic prototype gathering dust inside a research lab. According to reports, Toyota's new battery technology is already moving through pilot production in Japan, with plans aimed at mass market deployment. If these claims hold true, the consequences could be enormous. Not just for electric vehicles, but for the entire global energy industry. Because this is bigger than range, bigger than charging speed, bigger than cars themselves. The company that once revolutionized manufacturing may now be preparing to revolutionize energy, and what happens next could determine which automakers survive the next decade, and which ones disappear. Before we reveal how Toyota pulled this off, subscribe to the channel and let us know in the comments. Has Toyota just delivered the biggest breakthrough in automotive history? For decades, the EV world was trapped inside a lithium cage. For years, lithium-ion technology ruled the electric vehicle world. It powered nearly every major EV on the road, but it came with serious drawbacks. Charging times remained frustratingly long, battery packs were heavy, and the threat of overheating never fully disappeared. The industry knew a replacement would eventually arrive. The only mystery was who would get there first. Few people expected Toyota to be the company leading that charge. There was no flashy product launch, no massive live stream, no celebrity-filled event. Instead, the announcement emerged from a private engineering conference in Toyota City, attended by a small circle of executives, investors, and technical specialists. What was revealed behind those closed doors immediately grabbed attention across the automotive world. Toyota disclosed that its long-rumored solid-state battery project had moved far beyond the experimental stage. The technology was no longer a laboratory concept. It was functioning, tested, and delivering performance figures that seemed almost impossible just a few years ago. According to company data, the batteries had undergone extensive testing for more than a year and a half, and were already operating inside advanced prototype systems. The reported results stunned observers. More than 1,200 miles of driving range from a single charge. A complete recharge in under 5 minutes. Enough energy to travel across major regions without stopping, combined with charging speeds that challenge everything consumers currently expect from electric vehicles. Toyota wasn't presenting another futuristic concept vehicle. What they introduced was evidence that an entirely different battery era may be approaching. One phrase reportedly displayed during the presentation captured the moment perfectly. Beyond lithium. Those two words carried enormous implications. This wasn't being framed as an improvement to existing technology. It was being presented as a replacement for it. The reason industry leaders reacted so strongly becomes clear when you examine how these batteries work. Traditional lithium-ion cells rely on liquid electrolytes, a component that has been linked to overheating concerns and safety limitations for years. Toyota's design replaces that liquid with an advanced solid-state structure built around specialized ceramic-based materials. The advantages are substantial. Energy density reportedly climbs from roughly 250 watt-hours per kilogram in today's leading EV batteries to nearly 450 watt-hours per kilogram. In simple terms, significantly more power can be stored in a smaller and lighter package. That translates directly into greater driving range, improved acceleration, reduced vehicle weight, and better overall efficiency. Toyota claims its new battery packs are approximately 30% lighter and 15% more compact than those used in its current generation electric vehicles. But the benefits extend beyond size and weight. The solid-state architecture is strong enough to contribute to the vehicle's structural rigidity, adding another layer of safety and durability. Hidden within the design is another breakthrough. A graphene-enhanced anode dramatically reduces the formation of dendrites, the microscopic metal structures that gradually damage conventional batteries and can contribute to dangerous internal failures. Internal testing reportedly demonstrated more than 2,500 complete charging cycles while retaining the vast majority of original capacity. In practical terms, that could translate into well over 1 million miles of use before owners experience significant performance degradation. Temperature management may be equally impressive. Even during rapid charging and heavy performance demands, the batteries reportedly maintain stable operating temperatures. That stability helps reduce the risks associated with thermal runaway, one of the most discussed concerns in modern battery technology. Yet Toyota's ambitions extend far beyond the battery itself. The company is also developing a next-generation charging network designed specifically to support this technology. Known as the Hypercharge 55 system, the platform is designed to deliver an astonishing 2.2 megawatts of power through advanced liquid-cooled charging equipment. This pushes charging into an entirely new category. Instead of waiting 20, 30, or 40 minutes to continue a trip, drivers could potentially recharge in less time than it takes to make a quick stop at a convenience store. Of course, delivering that much power creates a major challenge. Most electrical grids were never designed to handle sudden demand spikes of that magnitude. Toyota's proposed solution involves large-scale energy storage systems installed directly at charging locations. These stationary battery banks would slowly collect electricity from the grid and then release massive amounts of energy instantly when vehicles connect. The concept reduces stress on local infrastructure while maintaining ultra-fast charging speeds. Safety remains another area where Toyota believes it has an advantage. The batteries are reportedly engineered to perform across extreme climates, from freezing northern winters to scorching desert environments, without swelling, leaking, or suffering severe performance loss. Even in damage simulations, the cells have shown remarkable resilience. Rather than igniting or exploding when punctured, they are designed to remain stable. Toyota has also subjected prototype packs to severe crash testing scenarios under demanding safety standards. Results reportedly showed dramatically lower heat propagation compared with conventional battery systems. In effect, the battery becomes more than an energy source. It becomes part of the vehicle's protective structure. Toyota may not have simply developed a better battery. They may have created an entirely new foundation for future transportation. If these claims prove accurate at commercial scale, the impact will stretch far beyond passenger cars. Long driving ranges, near-instant charging, enhanced safety, greater durability. Each one addresses a major obstacle that has slowed EV adoption around the world. A battery capable of traveling more than 1,000 miles and recharging in minutes would fundamentally change consumer expectations. And when news of Toyota's progress began circulating, reactions were immediate. In Japan, Panasonic was already closely involved. The company had quietly partnered with Toyota on pilot production efforts near Nagoya, signaling confidence in the technology long before the public became aware of it. Meanwhile, in China, leading battery manufacturers reportedly accelerated internal development programs as concerns grew about falling behind in the race toward solid-state technology. The pressure was intense. This was no longer about innovation alone. It was about survival. Across the United States, major automakers also took notice. Companies that had invested billions into existing battery platforms suddenly faced the possibility that an entirely new standard could emerge much sooner than expected. Engineering teams reportedly began analyzing patents, studying technical details, and searching for ways to respond. Because if Toyota's breakthrough delivers everything it promises, the competition may be facing a future they never saw coming. Suddenly, every forecast, every roadmap, and every industry model was being questioned. In Germany, Volkswagen's ambitious battery timeline no longer looked cutting-edge. It looked outdated. What had once been presented as the future now appeared to belong to the past. Within days, market sentiment shifted dramatically. Analysts who had been optimistic about the EV race began revising their predictions. The gap between Toyota and its competitors was no longer measured in a couple of years. Some experts estimated the lead could stretch 6 or even 7 years ahead. And the reason was simple. Most companies were still talking about future plans. Toyota was already gathering results, not in controlled laboratory environments, not through computer simulations, but in real-world driving conditions across multiple continents. Quietly and almost unnoticed, Toyota had deployed around 50 prototype vehicles equipped with solid-state battery systems. These test units were operating throughout Japan, North America, Europe, and even the freezing northern regions of Hokkaido. They weren't flashy concept vehicles designed for auto shows. They were disguised as ordinary production cars, hidden behind strict confidentiality agreements, and blended into everyday traffic. Yet beneath their familiar appearance was technology that could change everything. These vehicles faced some of the harshest testing conditions imaginable. Scorching desert temperatures, freezing mountain roads, continuous fast charging, heavy urban traffic, long-distance highway travel, the kind of punishment that exposes weaknesses fast. Instead, the data reportedly revealed something remarkable. Across mixed driving conditions, average range approached 958 miles per charge without requiring a single charging stop. And Toyota isn't planning to keep those numbers hidden forever. The company is expected to release public performance data next year. If the official figures align with internal testing results, the impact could reach far beyond the automotive industry. Because laboratory breakthroughs are one thing, real-world proof is something entirely different. And according to reports, Toyota may already have it. But the company's ambitions extend far beyond electric vehicles. Toyota's vision isn't limited to replacing gasoline engines. It's about reshaping how energy is stored and used everywhere. Beginning in 2026, the company plans to expand its solid-state technology into residential and commercial energy storage systems. From home battery units to large-scale utility installations, the same core technology could power an entirely new generation of energy infrastructure. The benefits are significant. These storage systems are expected to be lighter, operate at lower temperatures, last substantially longer, and reduce installation costs by nearly 20%. For homeowners with solar panels, that could mean storing enough electricity to power a house for nearly 2 full days without requiring larger battery banks or expensive upgrades. And in some of the world's most remote locations, from isolated Alaskan communities to distant Pacific islands, the technology could make fully renewable, off-grid living far more practical. Solar energy collected during the day could be stored efficiently and replenished in just a fraction of the time required by today's systems. This isn't merely a proposal on a presentation slide. Projects are already moving forward. These systems are designed to provide energy independence to places that have historically struggled with reliable power access. And remarkably, they rely on the same solid-state platform being developed for Toyota's future vehicles. The automotive division and the energy division are now advancing together, using a shared technological foundation. Then there's the supply chain advantage. Toyota's battery chemistry has reportedly been engineered to minimize dependence on many of the materials that currently dominate the global battery market. No cobalt, no nickel, and dramatically reduced lithium requirements. That alone removes many of the geopolitical and supply chain risks that have troubled battery manufacturers for years. At the center of the design is a proprietary ceramic electrolyte system that can be integrated into existing manufacturing infrastructure without requiring massive factory overhauls. In other words, Toyota doesn't need to rebuild everything from scratch. It can adapt proven production systems to support the new technology. Even more importantly, much of the material sourcing can be secured from domestic and allied suppliers, reducing exposure to international bottlenecks and geopolitical uncertainty. To strengthen that advantage, Toyota has already invested in new production facilities dedicated to key battery components. The result is lower transportation costs, shorter supply chains, and greater protection from disruptions affecting global shipping networks. Industry observers describe it as vertical integration taken to another level. Toyota isn't just manufacturing batteries. It's building an entire energy ecosystem under its own control. The company's goal is ambitious. By 2027, Toyota hopes to produce roughly 80% of critical solid-state battery components internally. If achieved, that would place the automaker in a position unlike any competitor in the industry. At that point, Toyota wouldn't simply be selling vehicles. It would be controlling a substantial portion of the energy technology behind them. And while competitors debated future strategies, Toyota was already moving into large-scale production. Inside the company's Motomachi facilities, pilot manufacturing lines dedicated to solid-state batteries are reportedly operating today. Together, they are capable of producing approximately 250,000 battery packs annually. These are not laboratory samples. They are production-ready units. Even more impressive is the reported manufacturing efficiency. Internal yields are said to exceed 90%, a figure many competing programs have struggled to approach. The key is automation. Advanced robotics handle delicate ceramic materials with extreme precision. Moisture exposure is minimized. Assembly takes place within tightly controlled environments monitored by AI-driven quality systems. The benefits are substantial. Production speed increases. Costs decrease. Defects become rarer. Human error is dramatically reduced. And Japan is only the beginning. Toyota's next major step is a purpose-built battery gigafactory in Thailand designed exclusively around solid-state production. Unlike facilities that must accommodate older battery technologies, this plant has been designed from the ground up for the next generation. No legacy systems, no compromises. Just a manufacturing platform built specifically for the future of energy storage. The first vehicle expected to fully showcase that future already has an internal identity. Known inside the company as the Toyota X1, it represents Toyota's first ground-up vehicle built entirely around solid-state architecture. And according to reports, its specifications are extraordinary. More than 1,200 miles of real-world range, a complete recharge in approximately 5 minutes, and a target price below $30,000. If those numbers become reality, the implications for the automotive market would be enormous. The X1 also introduces Toyota's cell-to-frame design, where the battery pack becomes a structural element of the vehicle itself. The result is a platform that's lighter, stronger, and more efficient. Reports suggest the vehicle could weigh nearly 30% less than a comparable SUV while delivering greater rigidity and improved safety performance. Toyota believes the model could eventually become its most successful vehicle ever, potentially surpassing even the legendary Corolla. Meanwhile, much of the industry found itself scrambling for answers. Automakers that had invested billions into conventional lithium-ion infrastructure suddenly faced uncomfortable questions about the future value of those investments. Expansion projects were reassessed, partnerships were reconsidered, long-term strategies were rewritten. Major battery manufacturers reportedly began exploring opportunities to access Toyota's proprietary technology, particularly its ceramic electrolyte systems, the same technology many critics once considered too difficult to commercialize. Now, everyone wanted access. And according to industry speculation, obtaining that access wouldn't come cheaply. Some estimates placed licensing discussions in the multi-billion-dollar range. Then came the market reaction. Over the course of just a few trading sessions, tens of billions of dollars in value disappeared from companies tied to older battery technologies and competing EV platforms. Investor enthusiasm rapidly shifted. Projects once considered revolutionary suddenly looked uncertain. One market analyst summarized the situation with a single observation. This is no longer a race for leadership. It's a race to avoid being left behind. Then Toyota delivered a statement that echoed throughout boardrooms, investor meetings, and industry conferences around the world. We didn't improve the car. Toyota didn't just improve an existing system. It removed the trade-offs entirely. The future is arriving faster than anyone expected, and trust us, you'll want to be here to watch it unfold.